Forthcoming in Admiral and the Pharmaverse. Welcome.
Okay, thank you. All right, so I'm going to talk quickly about what PK data is, types of PK analysis data, a quick overview of Admiral and the Pharmaverse, and then go through some programming steps, and then show some additional Pharmaverse tools that I'm going to be using. These are all present in a website that you can take a look at later. So quick pharmacokinetics overview. PK is the interaction of a drug with the body. Generally, samples are collected at regular time intervals after dosing, and then metrics are calculated from these. And there are two main types of modeling. So non-compartmental analysis and population PK. For non-compartmental analysis, this is individual based. It has intensive sampling, and this is where we derive parameters like AUC, Tmax, and Cmax, like with a typical PK curve as shown there. Population PK, or ADPPK, is population-based. It can be less intensive sampling, and it can be used to detect variations among populations based on covariates. So there are two currently CDISC standards that are out for these. Standard for the non-compartmental analysis came out in 2021 in November. The standards for PopPK came out just 2 weeks ago. So, and I'm going to focus a little bit on the ADPPK stuff because it's so fresh. So, like I said, here's the types of analysis data. There will also be coming a ADPP, which is the parameter files, and that should be coming possibly next year. So here are some characteristics of PK analysis data. They generally include both exposure and concentration data coming from EX and PC domains, for example. They will include relative time variables, both nominal and actual time. The ADNCA will include duplicated records for analysis, and the ADPPK includes numeric covariates for modeling. And you may need to do some things like expand dosing records or impute times. So here are some time variables for ADNCA: the nominal time from first dose, the actual time from first dose, the nominal time from the reference dose, and nominal time from actual time from the reference dose. Here's just a quick look at the difference between nominal and actual time. So there will be a scheduled set of time points for sampling, and then the actual time at which sampling occurs may be slightly different from that. So the nominal times will generally be used in displays of the concentrations, and actual times will be used in the modeling. So for ADPPK, they're pretty much the same: nominal time from first reference dose or from first dose, actual time from first dose, and then slightly different nominal time from the previous dose and actual time from the previous dose. And here's just a quick kind of overview. I've also included the dosing records here with EVID as 1, and you can see the times increasing after the doses. So ADPPK has some additional expected variables. So the event ID, the DV, which is a dependent variable, which would be equivalent to AVAL in most cases, and MDV, which is missing dependent variable, and BLQ. The reason for some of these are that the popular modeling software expects certain variables to be present. So, and then it also has covariates, as I mentioned, and these naming conventions. The baseline covariates will have BL at the end, so weight baseline, BMI baseline, for example. There will be numeric versions of categorical variables such as sex and race, with sex N and race N. Oftentimes there'll be imputed values, so these will end with an I, and then there are grouping variables for the covariates as well. So Admiral stands for ADaM in R Asset Library. It's open source and collaborative. Began as a collaboration between GSK and Roche, and now has many other companies and individuals working on it. It's a modular set of functions, so it's not one big function. It does have PK templates for both NCA and POP-PK, and there's a stable 1.0 release expected in December. So on the website for Admiral, you can find the link to the PK templates and vignette. And since it's module, I'm going to kind of broke it down into a couple different sets of functions that I use for the PK programming. So date time functions, such as derived vars DTM, merge and join functions, such as derived var merged and derived var join, derived vars transpose, and then also create single dose data set. And then some special purpose functions for computing things like BMI, BSA, and kidney functions. And so Admiral is part of the Pharmaverse, and if you look at the Pharmaverse website, you will see a growing number of packages and people involved each week. And I'm going to show a couple additional packages in addition to Admiral here. So from the Pharmaverse, so Pharmaverse SDTM has CDISC sample data. Metacore is used to store metadata, and metatools can be used to work with metadata and perform some checks. Exporter will perform checks and export transport files. So I set up an end-to-end example site, and there'll be a link to this. I'll share it later. And I'll focus on the ADPPK example here. So just some quick coding highlights. We'll load specs. We'll derive dates. We'll expand dosing records, find the first dose, find the previous dose, find the previous nominal dose. We'll derive our covariates using metacore. We'll do some checks with metacore and then exporter. So here's our load specs with metacore, and there's a link to the specs on the website as well. Derive PC dates. You can see first we're merging ADSL, and then we're using derived vars DTM to derive our dates. We'll expand dosing records. This is often needed in cases where you have data with a start date and an end date that are different. You can see this will expand the records and give you one record for each day in this case. We'll find our first dose. We'll use derived vars merged with the mode first in order to define that. We'll find the previous dose using derived vars joined. Derived vars joined allows us to do a filter based on data in each of the input data sets. So we're going to look at the date from the sample data and the date from the dosing data. Do the similar thing for nominal dose, and then we'll derive our covariates using metacore. So here's an example of create var from code list. Here's output of those. You have the numeric decodes from metacore. And then some additional covariates, weight, BMI, BSA, creatinine, and creatinine clearance. So we'll do some quick metacore checks, and we'll have our exporter code also to do the final output from this particular model. So just you can see what I've done. Here's some example website that I wanted to point out. So, and there's a link to that. You can check this out. Go through the PPK walkthrough. And coming soon, there will be a full website for Pharmaverse with other full end-to-end examples. All right, so thanks to the Admiral team, the Slack Pharmaverse PK working group, Luke Reinbold from the CDISC team, and Ben Straub from Admiral, who did some reviewing of this stuff. So thanks a lot. You can contact me. I'll try to post a link to the website, and you can see it in the expo as well.